Welcome to this tutorial on platform types in Kotlin. When working with Kotlin and Java together, one of the most important concepts to understand is how Kotlin handles types that come from Java code. Specifically, we need to understand what happens when Java code doesn't specify whether a value can be null or not. This is a critical topic for anyone doing Kotlin and Java interoperability, so let's dive in and explore how Kotlin deals with Java's non-annotated types. Let's start by understanding the problem. In Java, reference types like string don't tell us whether they can be null or not. Look at this Java code. We have a user class with a getName method that returns a string. But here's the catch. This string could be null at runtime, and Java doesn't require us to specify that. There's no way for the compiler to know whether this method will return an actual string value or null. This ambiguity is a fundamental issue in Java that Kotlin was designed to solve. This is where Kotlin introduces a special concept called platform types. A platform type is a type that comes from Java code where the nullability information is unknown. Kotlin represents these types with a special notation, an exclamation mark after the type name. For example, string exclamation mark means this could be either a nullable string or a non-null string. The compiler simply doesn't know. It's important to note that you cannot write this notation in your own Kotlin code. You'll only see it in error messages and IDE warnings when dealing with Java interoperability. So how does Kotlin handle these platform types? The answer is, it gives you the choice. When you receive a platform type from Java, Kotlin allows you to treat it as either nullable, using string with a question mark, or as non-null, using just string without any marker. If you choose nullable, you'll be forced to handle null cases safely, but your code might be more verbose. If you choose non-null, your code will be more convenient to write, but you're taking a risk. If the Java code actually returns null, you'll get a runtime exception. It's a trade-off between safety and convenience. Let's look at a concrete example. Here we're calling a Java method called getUser that returns a user platform type. When we call getName on that user, we get another platform type. Now we have two options. In option 1, we explicitly declare name1 as a nullable string with a question mark. This is the safe approach. Kotlin will require us to check for null before using this value. In option 2, we declare name2 as a non-null string. This is more convenient because we can use it directly without null checks. However, if getName actually returns null, we'll get a null pointer exception at runtime. The choice is yours, but choose wisely. Here's where things can go wrong. If we treat a platform type as non-null by assigning it to a non-nullable string variable, and then the Java method actually returns null, we'll get a null pointer exception when we try to use that value. In this example, calling .length on a null string will crash our program. This is the danger of platform types. They bypass Kotlin's null safety at compile time. The compiler won't catch this error because we told it the value was non-null. This is why platform types should be handled with care. Fortunately, there's a solution to this problem. Java developers can add nullability annotations to their code. When Java code includes annotations like at not null, at nullable, or at non-null, Kotlin can read these annotations and understand the nullability contract. In this example, the getName method is annotated with at not null, which tells Kotlin that this method will never return null. When Kotlin sees these annotations, it treats the types accordingly. At not null becomes a non-null Kotlin type, and at nullable becomes a nullable Kotlin type. This eliminates the ambiguity of platform types entirely. Let's wrap up with some best practices for dealing with platform types. First, always convert platform types to explicit nullable or non-null types immediately when you receive them from Java code. Don't let platform types propagate through your codebase. Second, if you have control over the Java code, add nullability annotations to make the contracts clear. Third, when you're uncertain about whether a Java type can be null, use the safe call operator with a question mark and dot to handle potential null values safely. And finally, never let platform types leak into your public API. Your Kotlin code should always use explicit nullable or non-null types so that other developers know exactly what to expect. Following these practices will help you write safer, more maintainable code when working with Java interoperability.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.